mark. Get set.
Wait a second. This runner is about to take off and flex his giant quadriceps. But what's actually happening when he contracts his muscles?
Let's take a look. The chain reaction that is muscle contraction begins in the axon terminal of a motor neuron, in this case, a Dixie cup. The neurotransmitters, or the little purple circles, let's say they are acetylcholine in this case. You may be asking yourself, what is acetylcholine? It is a chemical message that is used as a neurotransmitter to send signals to other cells. Neurotransmitters are released into the synapse and vesicles and bind to the receptors located on the membrane or sarcolemma of the sarcomere. This triggers an action potential in the sarcolemma, which travels down the T-tubule, where it triggers the sarcoplasmic reticulum to release calcium, a situation that will require ATP. Calcium then binds to troponin located on the actin. Calcium binding to troponin releases a signal for the tropomyosin to move away from active sites on the actin. The next part of the process is the sliding filament theory. It kicks off with the one and only ATP binding to the myosin heads and changing them to their high energy configuration, where they can now form a bond or a cross bridge with the now open active sites. On the outer edge of the actin, you can see the Z-line, which is represented by a black pipe cleaner. The actin filaments are all bound to the Z-line, which makes up the outer boundary of the sarcomere. Once a cross bridge is formed, the myosin heads relax back to their normal low energy configuration through power stroke, which moves the actin towards the M-line. Once again, we can see ATP come into play to break the cross bridge between the actin and the myosin heads, and at this point the muscle is fully relaxed. Now that we've seen the close-ups of muscle contraction, let's see if our runner can put it into motion.
Oh no, ¿qué pasó? Oh no, how did this small bull die, and why is its body so stiff? Well, we don't know how it died, but we can explain why its body is stiff. It is due to a little known thing called rigor mortis. Rigor mortis is the stiffening of the body post-mortem. It is specifically caused by the contraction in muscles after an animal has died. Let's show you how muscle contraction works when someone is experiencing rigor mortis. Before we begin, we must explain that when someone has died, there is no respiration because, well, they are dead. Therefore, not as much ATP is being produced in the body. Okay, first, just like normal muscle contraction, neurotransmitters will be transported from the axon terminal through the synapse into their respective receptors on the muscle fiber, exciting the sarcolemma of the muscle fiber and emitting an action potential along the membrane. This action potential travels to the sarcoplasmic reticulum via the T-tubule and permits the sarcoplasmic reticulum to release calcium. But since the animal is dead, its body and membranes of the body cannot regulate the number of calcium ions leaving the sarcoplasmic reticulum, leading to an overflow of calcium ions in the muscle fiber. Additionally, you have to remember that some ATP can still be produced in anaerobic processes. Thus, there is still some ATP left to open up the calcium pump. Next, all these calcium ions bind to the troponins of the thin filament and consequently freeze a myriad of myosin head binding sites. As stated before, there is a meager amount of ATP in the body, but there is just enough to energize the myosin heads so that they may be in a high energy state to connect to their binding sites. However, since there is an insufficient amount of ATP being produced, no ATP, or very little, are used to break the cross bridges between the myosin head and their binding sites. As a result, the muscle stays contracted. Although these muscles do not stay contracted forever, after a decent amount of time, the body will begin the process of autolysis, or the self-digestion of cells. The process weakens the muscles and allows them to become flaccid and weak, ending rigor mortis. In summary, rigor mortis is a temporary state of contraction that is a result of the lack of aerobically produced ATP. Now you know why the bull was so stiff after it died. Now let's get back to the race. Look at those muscles contracting.